Hi, in the previous video, we looked at the human eye, how it works, what are the cool things it can do, and we also looked at some defects of the eye and how to correct them. In this video, we will go to the second part of the chapter, that is the wonderful world. In this part, we will observe the beautiful things around us, like why is the sky blue? Why are the clouds white? Why is the sun red in the morning and evening, but it is white in the afternoon? So all these things we will look at. It seems really interesting, but it might get a little confusing also. So if it gets confusing, then don't worry. Just in the comments, put your doubts and I will answer them. Okay. So we have studied refraction through a glass slab. In the glass slab, what had happened was instead of the light ray coming straight like this, yeah, instead of coming like this, it has shifted by this much. It has not changed the direction, but it has shifted. This is known as lateral shift. Okay, this is happening. So this is actually not changing the direction because this surface and this surface is parallel to each other. But in a prism, what happens? These two surfaces are inclined because it's a triangle. Then what happens is incident ray. This is air, that is rarer medium. This is also air. This is also rarer medium. This is glass, so denser medium. Now, from rarer to denser, instead of going like this, it will be bent towards the normal. Okay. Then again here, this is from denser to rarer. Instead of going straight like this, it will bend away from the normal. So there are three rays here. So just for naming them, what are they named? The ray that is coming and incident on the prism is called the incident ray. The ray that is going inside the prism is called the refracted ray. This is called the ray which comes out of the prism is called as the emergent ray. Here also there were three: incident ray, refracted ray, emergent ray. Technically, what is the correct thing? At this surface, incident ray is this one, refracted ray is this one. At this surface, incident ray is this one, refracted ray is this one. But for convenience, people have named this incident ray, this refracted ray, and this as the emergent ray. Let us move to more details about the prism. So what a prism actually looks like is it has two triangular surfaces, okay, and three rectangular surfaces. See, one slope here, one slope like this, and then base it has one more rectangle. Okay, so three rectangles and two triangles, and the angle by which it is inclined is called the angle of the prism. Okay, if this angle is 60 degrees, then this triangle becomes an equilateral triangle, so that this prism is will be called as equilateral prism. Okay, in this chapter we will be looking at only triangular glass prism. See, if this is a triangle, then this is called a triangular glass prism. But if it was a rectangle, then it would have been called a rectangular glass prism. But in this chapter we will look at only triangular glass prism. Let us look at one experiment.
Hello scientific people. Today we are going to study the refraction experiment from the prism, and we are also going to measure the angle of deviation from the prism. And for this experiment you require a prism. Here we are using typically a prism whose angle of prism is 60 degree, equilateral prism, and protector, scale, few softboard pins, eraser and pencil. So let's begin with the experiment, and this experiment will be almost the same as the refraction through glass slab experiment. So what do we need to do is, first of all, take two softboard pins and fix it on the wooden.
So first of all, he is taking and fixing the paper just like the glass lab experiment. Then he will draw a boundary around this. Let us skip that part because we already know that. Let us skip to the part where he has completed drawing the boundary.
Okay, so here we have made the outline. Pardon me. Now we are going to make an incident ray, and the incident ray, say for example I wish to make the angle of incidence is 60°. I choose this point to be the point of incidence. So this part of the protector, I need to put it over here. Angle of incidence 60°. So we know that the normal would be 90°. So this is 90°. So 10, 20, 30, 40, 50, 60. So the 60° would be over here. We are not measuring the angle from here, otherwise it would be 30°. We are measuring the angle from 90° to 30°. That's why it is 60°. Mark a point on 90° as well. Now this would be your normal, and this would be the angle of incidence.
Okay.
Right?
This you have understood how he drew the incident ray. Now what he's going to do is he is going to place two pins on that incident ray, just like we did for the glass slab experiment. Then he is going to put the prism here back on the triangle, and he is going to try to view these pins from here and try to put two more pins so that all four pins are in a straight line. I'll show you.
Now you are supposed to see these two pins from this side. They will be visible to you. And now I'll be seeing the pin, these two pins from this side, because this is the incident ray, that would be the refracted ray, and the emergent ray would be somewhere over here. So I need to see the pins from here, and you need to see it very carefully with one eye closed to avoid the parallax error. So
Okay, I'm just going to skip this part because we already know it. He's going to place, by looking inside, he's going to place two pins again. I'll show you how it looks.
these two pins, when I was looking,
So when he was looking from here, it seemed as though these two pins are like this, like this. Why is it happening? Because the emergent ray is like this, so it feels as though these two, so the light traveling from here will be visible to our eye like this. So when we are seeing from here, it feels as if this is like this here.
at these two, if you
Yeah,
watch
now
these
here
two
he shows, see, these two pins are like this here. Okay, but here it's appearing as if it is here.
pins, these two green colored pins are visible over here, right? And now if you see that
see,
all
now from here it seems like it is actually in a straight line. Okay, so thus now by looking at it, he has put two pins. He will make those
four
dots and he
pins,
will draw the
very
emergent
carefully
ray.
mark these two.
Yeah, now he will draw the emergent ray and then determine the angle of deviation of the angle of deviation. I'll tell you what is angle of deviation. So this experiment shows that the path that we thought it will go in, the path that we thought it will go like this, and like this. It is correct because we are able to see the pins here only. Okay, let's come back to our presentation. Okay, so now what is angle of deviation? The incident ray on the prism was supposed to go like this if there was no prism. But since we have placed the prism, it is going like this. Okay, so by the angle by which it has deviated is called as the angle of deviation. Okay, so it was supposed to go like this. It is now going like this. So how much it has deviated its path? So this whole angle is the angle of deviation. Now let's go next one. First of all, what do you think is the color of light? Okay, it is very tricky question. So first people assumed that the color of light is actually always white, but because of some reasons, like for example, when the light passes through a red color glass, then it will become red light. So it was assumed that actual color of light is white and other colors were created by modifying the white light. But this prism experiment showed something new. Let us look at what that experiment is. In this video, I'm going to put the link of this video in the description. You can watch it, but some things are a little complicated and you might not understand. But whatever parts of this video you need to show, you need to know, I'm going to explain it here. Okay, whatever is there for 10th standard syllabus, I will explain it.
In this video, we're going to look at the relationship between white light and color by recreating a portion of Newton's prism experiment as presented in a letter to the Royal Society in 1670.
We can skip these parts and go directly to the experiment. See, as I said, before people thought the color of light is white, but
the theory was that white light was a color of light and that other colors could be created
by putting red glass, the white light became red. So this is how people thought different colors light was created. Okay,
modifying the white light somehow. For instance, this red piece of plastic will be described as changing this white light into red light. They also had knowledge about how light behaved at the boundary between two materials. For instance, at a planar boundary, they knew that the ratio of the sine of the angle on each
this we anyway know. Let me forward to the
fast light propagates through it. This expression allows us to predict what will happen at a planar boundary as we change the angle of incidence. And it also allows us to deal with more complicated shapes, like this triangular prism. It's just a matter
this prism, nice it is.
Matter of geometry and keeping track of the angles.
Yeah, see, it is coming like this, refracted like this, and emergent like this.
Newton was working on designing lenses.
That was red light. Okay, now see what happens when white light is incident on it. Before here, we see a red light is incident and it refracts like this. It is still red light after this. But when white light enters, what will happen? Let us see.
The angles. Newton was working on designing lenses for telescopes when he decided to investigate the phenomena of prismatic colors. Those are the colors that occur when you pass white light through a prism. So he obtained a triangular prism, and he passed some white light through it, and he saw a rainbow. Just
see how beautiful. White light is coming from here. After it passes through the prism, you can see that it actually has become it has split into several colors. First color is red, yellow, green, orange is there in the middle. So it's Vibgyor. It has split into 7 colors. It starts from violet, which is little dark, blue, indigo, Vibgyor, green, yellow, orange, and red. Okay.
Just like he expected. But then he noticed something. In the direction that the colors were spread, the pattern was much wider than it should be based on the system geometry if light obeyed this fixed sine ratio law. So he did some experiments. He separated out.
Okay, I'm going to explain more parts later, but this is the basic experiment that you should know. What happens? This is process of dispersion. So when white light enters the prism, it splits into 7 colors. So this is called as dispersion. We will look at more about it. Okay. If you want, you can watch this video, but if you get any doubts, then you can ask me. For 10th standard, most of the things that he has said in this video is not there. Let us go back to our presentation. So what happened for our thing? Assumption about color of which is white. We thought color of light was white, but when white light has been passed through prism, which is colorless, prism is just glass which is not having any color, still we got 7 different colors. So it means the assumption of actual color is white is wrong. So what is a better way to explain the colors is that the white light is composed of all the colors. Let us see. First of all, I told you what is dispersion. This is the splitting of white light into its component colors, that is Vibgyor, okay, is called as dispersion. Now let us see what, first of all, what do you mean by component colors? It means here we are saying that white light is composed of all these colors. So when we are looking at white light, all these colors are coming to our eye at the same time, because of which we are able to see w- a, like a combination of all these colors. So when we combine all these colors, it becomes white. Hard to believe, right? I mean, how can blue, green, yellow, red, all these colors combine to form white? I mean, if you have done some painting, you will feel like it doesn't make sense. But I'll show you. The painting is different than actual light color. Okay, so what happens is when these colors, when the lights of these colors are incident on the same spot, okay, together, then you see white light. Let us see. What I'm trying to tell is, if all these light rays are parallel to each other and they come on and fall on the same spot, see here it feels like it is far apart, but actually light is very small, so these are very close together. And if it falls on your eyes, here in this, the rays were not parallel. See, this is different angle, this is bent by different angle, this is bent by different angle. So because of this, it is all uh, not parallel, and it is appear it as you go farther away, it will be more and more farther apart, so you will see them separately. But if they were parallel, okay, if all the colors rays were parallel to each other, then we would see them together at the same time, then we will see white. Okay, that is what we have Newton concluded after this experiment. And to show that, he showed it using this Newton wheel. Let us see here, when the wheel is not moving, it is these colors. When the wheel starts moving, it completely feels like it is white. See how nice. So see, now he's switching it off, all colors are there. He switched it on, immediately it becomes white. It is just rotating. What is happening here is, because this is rotating so fast, all these colors, so because it is rotating so fast, we feel like all the colors are coming to the eye at the same time. So if all, wait, I'll show you. I can't pause this, I think. uh See, here yellow was there, okay, and beside that red was there. Now because it's turning so fast, here yellow was there, then red is coming in that position immediately fast. So because of that, because all the colors are coming fast 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 fast, we feel like all the colors are coming to our eye at the same time. Okay, at the same time, because of which they're coming, we feel like it is white. Understood, no? So all the colors are coming to our eye at the same time, parallelly, because of which we feel like it is white. But through a prism, what happens? They're not parallel. So that's why we can see different colors of light. See, if we have three lights here, red, green, yellow, you might have seen some lights that they use for dance. In that thing, what they do is they have three lights, and if they combine two lights, then it will become a different color. That's why when they're rotating the lights, so many colors are formed on the dance floor. See, red light and green light, if they mix, it will form yellow. Green light and blue light, if it mix, it forms cyan. Magenta is red plus yellow. No, red plus green. And blue plus green is magenta. Now, combination of all these colors will give us white. Okay. So here, as you can see, wherever it is inclined, so these are parallel. So when this is coming like this, whatever light is coming to our eye parallelly will be all white light, because those are all the light which are combined together. Okay, now one more very important thing is to notice from this experiment is each color deviates by a different amount. What does it mean? Here each color, so see, here we had seen this is the angle of deviation because this ray has deviated by this much. But here we are seeing there is no one ray that is deviating. There are 7 rays. So one ray is actually deviating by this much. So for this, angle of deviation will be what? For this, let let us draw. So it was supposed to go like this. It is now going like this. Angle of deviation will be this one. Now for this one, angle of deviation will be this one. It is more. It is actually more than this one. Similarly, this deviation is more. Green's deviation is even more. Which has the highest deviation? Violet. Now, when it is deviating more, we know the formula for refractive index is sin I by sin R. Correct, no? Let us stop clear. Okay, so we know that sin I by sin R is the formula for refractive index. So in the situation where it has deviated this much, sin I by sin R will give refractive index of medium 2 with respect to medium 1. But because these colors and all are deviating in different way, so this is violet. Violet is deviating the most. Okay, then comes Vibgyor, indigo. Indigo is, I think, I don't know, I think let's keep this. Uh, yeah, indigo is deviating little bit lesser. Blue. Blue is deviating more. Okay, it is violet is the most, then comes blue, sorry, then comes indigo, then comes blue. Okay, so this blue comes here. Now, finally, where is red going? I'll just draw red directly. So maybe red goes here. In between, there should be Vib, GYO. So 3 colors should be there here. Finally, red will come. So each thing is getting deviated by a different amount. Each color light is getting deviated by a different amount. This means for violet, in angle of incidence is this one only. Angle of refraction is this. For blue, it is this. For for indigo, it is this. For blue, it is this. For red, it is this. So sin I by sin R for all of this is different. So each color will have a different refractive index. How cool is that? So when you have a white light incident, then you have different. If you have a red light incident, it has a different refractive index. If a blue light is incident, then the refractive index is different. See how we did not know this before. Now new things we are able to know. Okay, let us go further. Now you should get this doubt. In glass slab also we sent white light only, but how come it did not separate? I'll tell you. I have told you that if all the colors are parallel to each other and they come together, then we feel like they are white color. So here I have told you that the light, because these surfaces are parallel, does not change direction. It only changes its path. Okay, it only shifts. So now it has actually dispersed, and it has, see, as we have predicted, violet has deviated the least. Sorry, violet has deviated the most. Red has deviated the least. Okay, but after this, again red will be here, violet will be here. They both will become parallel to each other. Parallel. So when we are seeing from here, okay, because our eyes, this distance is so small, our eyes cannot perceive that much distance. We feel like as though they are together. So because of that, we feel like these are all coming at our eyes at the same time. When that happens, it means here it is actually white color. Here also, when we thought it was white, it was still a combination of colors only. This white light, we thought it was a single this thing, but actually it was composed of red, okay, and violet, everything, but like it was spaced so close together that we cannot see. Here also the space is very less only, we can still not see the difference. So we feel like this color light is also white color, but here they are not parallel. That's why we are able to see the rainbow colors. How cool. Okay, clear. Now this is very similar to rainbow. How is a rainbow formed? Just like how dispersion happens in the prism, here also there is this surface. So wherever there is refraction, so here also there is refraction, there we will get dispersion. Okay, we will the colors will bend in different amounts. But if the next surface is parallel, then everything will combine together again. But if the next surface is inclined, that is if it was something like this, okay, then again we could see different colors. So on this water bubble, what happens, this surface again, it has become 7 colors from white color. Then after that, there is something called as total internal reflection that happens. That is a different phenomena, but you will not be studying it in 10th standard. It's not there in your syllabus. So what happens is something called total internal reflection happens, and you get a rainbow. Okay, because this is not parallel to this circle, it is. So this is also curved, this is also curved. So these light do not recombine and become parallel, they are still deviated only. So that's why for our eyes we will feel like it is different colors. That's why see how nicely we can see first first color in the rainbow will be red because it is least deviated. Then final color will be violet, that is most deviated. Okay, atmospheric refraction. Okay, I'll show you one video for this. ಹೋಮ ಎಲ್ಲ ಮಾಡ್ತಾ ಇರ್ಬೇಕಂದ್ರೆ ಮನೆಯಲ್ಲಿ ಈ ತರ ನೋಡಿ ಆ ಹೊಗೆಯಿಂದ, if we see, not just the smoke, because the air has become very hot here. If you see through that, you feel like these are dancing. We feel some wavy motion is going on, right? Why is that happening? That is because, I'll show you. That is because when we are considering hot air will be little more transparent than cold air, because in hot air what happens, the air molecules will become farther apart because it has been given more heat energy. But in cold air it is not that much. So hot air will become more transparent than cold air, because of which when the light is traveling from cold air to hot air, it will bend, because it is cold air will be the denser medium and hot air will be the rarer medium. So it will bend away from the normal. What is happening, if this is a hot road, then just the air that is just above the road will be very hot. Then little more above if we go, it has become less. Gradually it will become less as we go above. But so that's why when the sunlight is coming like this, when it comes here, bend away from the normal, again 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 bend away from the normal. I think this is reflection. After that again, here it will bend towards the normal. It has to travel like this. Now it has bent towards the normal, again towards the normal. So this is what is happening. Let me show you. Now what happens because of this is, here we have in atmosphere also there will be different layers of air which are at different temperatures. Here on the ground it will be very hot initially, but towards the end it will be cold. What will happen is, because of this, we feel that sun has risen even before the sun has actually risen. So sun actually will be here only. What this ray of the sun is coming like this, it has bent towards the normal, because obviously vacuum is more transparent than anything. So vacuum to air, it has bent towards the normal. Then here, colder to hotter, away from the normal and all those things, finally it reaches us. So we feel like the sun is actually here. So that is why we feel, even though the sun is not yet risen, we still feel like sun is already up. Okay, this is also because of atmospheric refraction. Again, atmospheric refraction, delayed sunset. So the sun has already gone down, but we feel like it has not gone down yet because of refraction through the atmosphere. Okay, also, wait, I will show you one more thing. Just like that, we saw in that ಹೋಮ ಮಾಡ್ತಾ ಇರ್ಬೇಕಂದ್ರೆ we saw some wavy nature, right? Similarly, that that is the reason in atmosphere also, because there are different layers of air, the stars are appearing to twinkle because of the atmosphere. Okay, this is due to atmospheric refraction. See, ಆ ಹೋಮ ಮಾಡ್ತಾ ಇರ್ಬೇಕಂದ್ರೆ ನಮಗೆ ಏನಾಯ್ತು ಇಲ್ಲಿ, ನೋಡಿ ಹಿಂಗೆ ಬುಳುಕ್ ಬುಳುಕ್ ಅಂತ ಒಂಥರ ಇಲ್ಲಿ ಅದು ಅಲ್ಲಾಡ್ತಾ ಇರೋ ತರ ಕಾಣಿಸ್ತಾ ಇದೆ ಅಲ್ವಾ, ಮರ ಅದೆಲ್ಲ ಅಲ್ವಾ, ಆ ತರ ಕಾಣಿಸ್ತಾ ಇದೆ. ಸೊ ಹಂಗೇನೆ ಸ್ಟಾರ್ಸ್ ಆಲ್ಸೋ, that because it will, because the air in the atmosphere is of different temperatures, it will appear to twinkle. Okay, twinkling of stars is also caused due to atmospheric refraction. Now this advanced sunrise and sunset also have explained.